All right, I think we can go ahead and get started. So we got a lot on the agenda today. We've skipped the last couple of meetings, so I think items have been piling up. First item is from Hemant, volume resizing and next steps. Hemant, do you want to talk about this?
Yeah, sorry, I was trying to. So there are two different items on this list actually, and maybe I'll share my screen. Let's see if Zoom will allow me to share my screen. Sorry. Okay, so there are two items on on this, the resizing follow-up. Obviously, I have to update the PR. I think, oh, it still has everything, no conflicts, good. So the first one is the we are planning to we have been trying to deprecate the plugin's ability to declare online and offline capability that could be declared via plugin level capabilities. So that is to say, we are not saying we are not unsupporting, we are not removing support for online or offline expansion. It's just that we are removing the explicit plugin capabilities because CEO has difficult time following this to the spec because deciding whether volume is online and offline is kind of racy and error prone. So it's CEOs are not implementing this correctly anyways. And instead the plan is to rely on failed precondition error if the controller expansion is called while the volume is online and the plugin cannot support online expansion. So to this end, we already made changes in 119 in Kubernetes, at least, that it respects this error and it doesn't retry volume expansion. And so I think at this point where we are is to have a look at the PR and like decide on the wording and go from there. Actually, like there isn't, I thought we had broad consensus about this. We did not want to do this in 1.3 release because of like CEO's behavior and everything, but yeah. So what does people on the call think and what we can do on this one? I'll just add it here that this is about.
So there was something about adding new tests to verify what happens with this, or to verify that people follow the new behavior. Did that happen?
Well, just let me just grab a. So that was about the next one actually.
Oh, okay. I'm getting it mixed up. Yeah, I don't think we ever had a problem with this because we certainly don't have problems with online expansion.
Yeah. So this is more like, all right, you plugins cannot implement this, the CEOs cannot implement this correctly. So it's pointless to have it in spec and it causes a lot of confusion. So yeah.
Yeah, I can help take a look at that and help get it merged.
Okay. The next one is the, where like what Ben was talking about. So there are two changes here that is there. One is that the first one is, which was relatively non-controversial, which was if a plugin does not support expansion of read-only volumes on the node, then it may fail precondition error and CO must not retry, because there's no way, if the volume is already either controller published as read-only or node published as read-only, there's no way the expansion is going to succeed on this node. So it expands that error to say volume in user read-only, indicate that the volume corresponding to cannot be expanded, is as read-only, and yeah, node the storage provider does not support stage or read-only volume. So this was, I think, relatively not problematic. This was fine. But where we had problem was that we want to deprecate right now the fact that that a plugin right now we wanted to deprecate the plugin may support a CO may call node expand between node stage and node publish. So we want to remove that support and we want to change the wording. I think in the last call, if we go to the notes, James suggested that that uh, CO should call node expand after node publish. So this was the wording that was previously, yeah, should be
Okay,
called.
so we're not forbidding it because it was previously allowed. We're just saying you shouldn't do that because bad things might happen.
Yeah. So just copy it here. Sorry. So for the next one was like there are two items in this one, and one was read only handling and node publish being called between node stage and node publish. So the previously
node expand, right? Node expand being called between.
sorry. Yeah. So the if we just see the spec as it exists, then it says okay, it says that if a plugin support expansion via offline, okay, that's different. Okay, those things will be anyway removed, but the wording says that node expand only support expansion of already node stage or node publish volume. A plugin has stage unstaged capability. The node expand call must be called after successful node stage, and this says node expand volume may be called before or after node publish volume. So this line should be renamed to node expand volume should be called after node publish volume. That is what we decided, but we didn't want to do because in case we break plugins. So I'll just add a note here, that line.
So didn't we talk about changing the CSI sanity test or something so that
Yeah,
we could validate that like we weren't going to break anything, and then once we validated that,
yeah, we did all that. So we have updated the CSI sanity test to check this, that the driver, if it implements node expand volume, it must support node expand after node publish. So we did that sanity check actually. We already added in
great.
the sanity test, and we also deprecated the support for doing this in Kubernetes in 190. That it will be removed in the future. So previously sorry.
Sorry, I was just going to say, can you add a note to that effect here, just for people who will be reading the notes?
Okay. Just trying to find what repo, but no, I think it was in the CSI test. Yeah, so I can update the existing PR that I have. I have not updated this PR yet with the wording change that we decided actually. So I need to update it, and I think the read only, and that will simplify some of the assumptions that we have, and it will simplify this PR actually. And I can do that like today later. So, but yeah. So should we write down the conclusions, or what do we decide on each item? Like I think I skipped the first item before drawing the conclusion. So it will be review, and is that fair that the first one, like we had to review and merge via GitHub peer review, it will follow the typical process, or is there anything else that we need to discuss on this one?
No, I think that makes sense.
Okay. The second one, the read-only bit was obviously, that was not a problem, but this one, is there anything else that we need to discuss on this one?
So we are actually right now trying to run the sanity test. Since we are running those for the first time, so we actually have some other issues we need to sort out before we know for sure that this one would work.
Okay, so you're saying
So
that
I will get back to you. I think it should work, but I mean, of course, we need to pass the test before I can tell you whether we have any issues or not.
Yeah, okay. So the sanity tests are obviously running for a bunch of drivers when we make the change, and they're passing, but yeah, if other drivers, they don't implement it. So I'm fine probably with waiting for like if you want to do that. Are there any other concerns on this one? It does mean that like I think the storage providers can simplify some of the assumption. I know Ben's plugin was doing something if the node expand is called after node stage but not published, so it would simplify the implementation if anything. Correct me if I'm wrong, but
it would simplify it if you only cared about Kubernetes, but as long as the spec says you might call it between node stage and node publish, you kind of have to deal with that possibility in your plugin.
Yeah.
If you want to be spec compliant. So it doesn't really get plugins out of jail unless they just don't care about anything other than Kubernetes.
So previously the wording says node expand volume may be called before or after. And now it will say node expand volume should be called after node publish. So like before the wording, it did mean that if the plugin wants to be spec compliant, it should support before or after both.
No, it must. Like that, the old wording was very clear. It must support both.
Yeah, exactly. And now it's like it should be called. So
I don't know. I mean, I can see there being plugins now that only support it calling after node publish, and just not bothering with the other case and knowing that it won't hurt them, but they technically won't be spec compliant, and I don't know what to do about that.
I mean, I think that's okay, because I think the whole point of using words like should is that, you know, if you want to be not necessarily 100% compliant, but you want like a very high probability of success, right? For working with all COs, right? you know, if you follow the recommendations, like, you know, that should get you there.
Yeah.
You know, if you don't handle the edge case, maybe it won't work with a CO, right? But I think we decided that that was going to be okay. Like, as long as people were kind of following the recommendations of the spec, that should kind of be your get out of jail free card for the most part, right?
Yeah.
I
I mean, I guess
someone
those of us
please.
who've already coded the workarounds to support the non-should case probably will leave them in just because the code works. But yeah,
Sure.
someone writing a new one probably might not bother.
Yeah, and I think I'm okay with that.
Okay, so we'll wait for Xing to verify some of the stuff, and then I will update the PR. And we will go from there on the GitHub. Is that fair?
Yeah.
Okay. One more item before I just conclude is, like, one of the things that we have been trying to solve in Kubernetes is recovery from resizing failures. And it's not yet in a PR, and I apologize for that, but there's a lot of discussion going around about this, and the fact that if you make a typo, then resizing is tried forever, retried forever, and it takes quota even though you are not using it, and blah blah blah. Those are the problems. So we have tried to fix this in Kubernetes by making it possible to reduce the size, even though obviously we don't support shrink. But in that case, the quota is not returned back to the user because the plugin may or may not have succeeded the expansion operation. We don't know for sure. So we don't return quota back to the user when user reduces the PVC size. So that's the thought currently, but we are getting like guidance from like SIG architecture, like people like Tim Hawkins, that it should be possible to return the quota when the resizing operation hits a terminal condition. So it should be possible to return quota when resizing hits terminal condition. So
Do you think this might need a CSI side change? I thought it's a Kubernetes side change only.
yeah, it was Kubernetes change, but because we are talking about, like, I just wanted to bring this in front of the community, like the returning the quota is very tricky problem, because we don't know if the operation like failed and the cloud provider did not even attempt it, like the storage provider did not even attempt it and failed, or we don't know if it attempted it and is in progress, but something happened and it failed, but it might be successful behind the scenes. So we don't have a way to like differentiate the operations that have failed with, like, you know, like kind of a permanent failure, like, okay, this is it, this has not happened, this did not work. Like, that's the reason I'm bringing it in front of the CSI community, because, like, for example, in case of AWS, like as an example, the AWS, like user resizes the volume, there are some things that are like failed precondition or authorization failure. In those cases, we know that the operation did not reach the storage provider, and we can return the quota back in those cases.
So I guess the ask here is to identify which cases are terminal cases and make the recovery behavior clear.
Yeah, yes. But there are cases where, for example, like the the request was sent to SP, and now we are polling for we are polling for updated status. So this is how typically, like at least in AWS it is implemented. Other cloud providers or other storage providers also implement similar logic where they expand the volume and then they poll if the volume is expanded or not. Like
I thought we only did that for create snapshot. Did we do that for other
No, I
calls?
think he's talking about down inside the driver
Yeah.
code. You don't return from the RPC. You just poll internally.
Right.
And the
If
timeout.
there's a network timeout, I see.
Yeah.
So there could be failure, like in this case, like you said, network timeout. But one of them, my favorite one is you're out of API quota with the cloud provider. Like the AWS is a
Would
quota.
that be a terminal error?
That's the thing. We don't know if the API quota failed when the first time we sent this request to SP, that returned API quota error. And in that case, so like actually the driver knows, but the error condition that it could return to the CO, how do we differentiate? So there are two cases. Like, okay, modify volume was called by the driver, by the CSI driver on the storage backend. And that call resulted in API quota error. So this means that maybe the operation was not tried at all on the storage provider. So that is one case. The second case is operation was sent to the storage provider, it accepted it, and now we are polling for updated volume size, and we receive, because we are polling, we are consuming API quota, we got the API quota error from the.
Oh, an API quota. Like,
Oh, I
you
see.
called too many APIs.
Yeah.
I mean, so in that case, then you can't return a terminal error because you're not sure.
So, but the operation might have succeeded on the cloud provider actually, because
Yeah,
Yeah, but I mean,
there's no
so
defined
you
error that you
return,
can safely return. So you have to just sleep until the timeout.
yeah.
Wait,
Or you
wait, sorry.
return, I don't know, and then we retry, and then on the retry it says it succeeded.
Right, but what happens if user shrinks in between in between that thing? Should we give the quota back or not?
Well, no, because the operation was still in progress. So it's up to the storage provider to understand and return proper error codes if a operation might still be in progress or not.
We don't have, so there are like it
Yeah,
sounds like gRPC code error codes. We don't have the error codes that we could use. So in most of these cases, we are just returning implementation, returning codes.internal. I think that's gRPC code. That's the gRPC code that most drivers return.
So we have error codes, specific error codes defined for other CSI calls.
Yeah.
Maybe we need to extend the specification to explicitly state those error codes for the expansion operation.
I agree. There should be at least one that says, return this error if you just don't know, and the CO will interpret that as it needs to retry.
Yeah, like I think for other operations, there's like operation exists or something like that, or operation in progress.
I think internal error is a pretty good one because it doesn't suggest that it's terminal. It says that something went wrong. You have to try again until you get a terminal error.
Okay. Already exists. So
I think that's different. There's like a in progress or something.
I don't see it.
But in progress is a Linux thing, not a gRPC thing.
Yeah, there's no error code for in progress operation in gRPC error code. I looked.
I think internal error might be the best one you have for that case where like you think it might be going on, but you can't find out, and your only options are to wait or give up.
But but that's not good enough. That's not good enough, because the internal error code could be that the error was terminal, and like, for example, if we try
No,
to
but I mean, like in the API contract, we have to define that, you know, if an internal error happens, the CO cannot assume that was a terminal condition and has to try again. And if the SP knows that like it definitely failed and is not going to happen, there's some other error code you have to return to indicate that.
Yep.
how do we do that? How do we return some other error code? Because so the way I'm seeing it, like when we SP when the CO calls control expand volume on the SP on the driver, then the first time the driver does a describe volume, and the describe volume call itself, for example, may run out of API call quota and it return error. And in that case, we also return codes that internal. So in that case, we have not even entered the expansion operation and we return codes internal. So there must be some error code that tells that, okay, this operation was not right or was in progress. So distinguish between.
There is a aborted 10 aborted operation pending for volume. So that's like an in progress type of thing.
Don't return. Yeah, I mean,
I really hate gRPC error codes.
Well, I don't know why this one. Yeah, this one says I don't even matter. But if you go to the I think volume one, it says operation pending for volume.
But Hemant, the case you described where like you didn't even get started because you're out of API quota, you don't know for sure that like it didn't succeed, right? Because it might not be the first time this was called.
yeah.
So like it's if you don't know, you can't tell the CO that you know.
So I think there should be like an operation exists or something, because I remember in our CSI driver, we explicitly changed a bunch of return codes to check if something is in progress already and return that error code. I'm trying to find the actual change.
It's in my Google search history. It's not there. It's not there, but yeah, okay. Aborted is closest to what we have actually, what like Xing said, but anyway, so wait, did I lose my tab?
I think we can agree that we have to expand the error codes enough that Kubernetes can tell the difference between a terminal error and a possibly non-terminal error. And it doesn't matter a whole lot what the error code is, as long as it's clearly spelled out what the recovery behavior is.
Yeah. I agree. And I think that like the giving back quota is super tricky without like some kind of additional error codes from CSI driver. All right. So I think I didn't expect to make a conclusion on this one, but I will write something down as an issue. Maybe we can follow up it in follow up this things else because I don't want to take too much of time. Too many issues to go through. Is that fair or like?
Yeah, I think so.
Yeah, I think we're going to need to go through these case by case and then define what the expected error code is and make sure the recovery behavior makes sense.
Okay. I'll stop my screen sharing. I'll hand it over to Ben.
Okay, how do I do this? I'm not good at sharing my screen. All right. So I've written down, everything I have here is written down in the meeting agenda. If you want to follow along, I'll share it. So those of you that were at the Kubernetes SIG storage meetup in San Diego know that I am very interested in how to reliably clean up messes after something goes wrong. And I've been thinking about this for a while. And I don't really have like I don't have a solution design, but like I've identified, I think, all of the pieces at the CSI layer that would need to change in order for a solution to exist. So I wanted to sort of run these by you guys, and if we can reach some agreement, I can start prototyping and propose a change, and then start demonstrating that this actually works. So I first want to talk about like controller publish, controller unpublish, and the way that it's specified today. So I think in reality, I've identified sort of 5 states that volume node accessibility can be in. And there's read write allowed, there's read is allowed, but write you don't know. There's read is allowed and write is definitely disallowed. There's both read and write are unknown. And then there's both read and write are definitely disallowed. And I'm pretty sure that you're always in one of these 5 states for any given volume n node. So the CSI spec defines the controller publish will transition you either into states 1 or 2, the read write allowed or read allowed write unknown state. And controller unpublish is defined to transition you into state number 4, read write unknown. There is no wording anywhere in the CSI spec that allows you to like definitely disallow access to a volume or to a node from a volume, or to a volume on a node. So I would like to define a way to do that. And I don't know if, I mean, the most important one is to be able to transition into the read write disallowed state. So if you definitely want to say, I do not want this volume to be able to access this node at all. I think there's also, it's less interesting to me, but for completeness, we should consider explicitly defining a way to transition into read allowed and write disallowed, so that you know that the volume is definitely not writable, but it is readable. I think that has some useful applications, not for me, but for other purposes. And I just wanted, and because this is an extension and not all CSI plugins will necessarily even be able to do this, we need to have a capability bit that says, you know, I can deny access explicitly to a volume, to a node for my volumes. So like, I don't know if it makes sense to layer on top of the existing controller publish and controller unpublish RPC calls, or if we should make entirely new RPC calls. I wanted to get your guys' opinion on this before I sort of sketch up a prototype.
Is this so? Are you suggesting that these read write states are dynamic and they can change?
Yeah, well, I mean, so the way the CSI spec is written today, you know, everything starts off in the unknown state. You don't know if a node can access a volume, but in order to make sure that it can, the spec says you must call controller publish first and get back a successful result before you can presume that it is accessible. And then when you don't no longer care that it's accessible, you call controller unpublish, and then at that point it either remains accessible or becomes inaccessible. You no longer care. That's how the spec is written. And so it's up to the CO to sort of keep track of the state. Have I published it? Have I unpublished it? You know, so that I know if I can make it, if it's accessible on a given node. And this would be a further way to say, you know what, I really don't want it to be accessible on this node. I want to be sure that it's not accessible, so that I can make other assumptions, like I can safely publish it to a different node and have that, you know, and go on with the volume being used on that node, and not worry about some other workload continuing to access it that I can't stop. Because so I mean, to pop up a level and talk about the use case a little bit, the case I'm interested in is like the node that is using the volume goes out of quorum. I can't talk to him anymore, and I'm not patient enough to wait for the node to come back into quorum, because I don't know how long that's going to take, and this is an important workload to me. So I want to reliably kill that node's access to all of the data, and then start up my workload somewhere else that is still part of the cluster, knowing that that's not going to result in any data corruption.
But how do you do that in a way that's safe for all applications that might be trying to use that data, or might have like pending rights?
So
Like,
it's going to depend on the application, because I mean, so there's a few cases, right? That one case is like the node already crashed, right? The node is dead. The application is not running. It left the volume in whatever inconsistent state it left it in because it crashed. And so like in that case, someone's going to have to start up the workload again and clean up the mess and replay whatever journals you have. You know, it's going to be application dependent how you recover from an actual crash, where the node just died. So what this does is it says, okay, you know, if I don't know whether it has crashed or not, I can simulate a crash by basically cutting off his access and saying, okay, you can't write anymore. You may have buffered writes that you were planning on sending, but then I'm just cutting them off and saying, you know what, I can't reach you, and I want to start the app up somewhere else and run the recovery and be up again. So the idea is provide a mechanism to allow that to happen. And yes, like you will lose some data if the app actually was still running and you do cut it off, but it's no worse than an ordinary crash.
So I remember we talked about having this as a flag on controller unpublish. So
Yeah,
are
well,
you think,
so that was my original idea, was, yeah, like a controller unpublish force kind of a behavior. But after coming up with the full list of states and realizing there's actually a couple of different states that are sort of covered by the controller publish call, and it's not the tricky one is state number 3, where it's read is allowed and write is definitely disallowed. So like, I don't think you would want to call controller publish or controller unpublish to get into that state. Or I don't know, maybe we could have a flag on controller publish that says make it readable and definitely not writable or something, and that would only work if the plugin asserted that capability that it could do that.
Doesn't the controller publish already have a read-only optional flag?
Yes,
that you
yes,
can opt into?
but what it is defined to mean is it must be at least writable. I mean, it must be at least readable, but whether it's writable or not is undefined.
I see.
the one problem, like I said this, I think I've said this before, is like, even if we add the new RPC call or add a flag, right now, like the way at least Kubernetes is implemented, it's not going to make use of it actually.
Well, yeah, so part of my work is going to be to make use of this, but I wanted to start at this layer and see if we can figure out a set of RPCs that Kubernetes could use to achieve this behavior, get them into the spec as optional capabilities, and then build the Kubernetes side pieces to take advantage of this. Because it will be very complicated to do on the Kubernetes side, but I want to make sure that we've thought through the primitives. And the second part of this is almost more important, but I wanted to start here on the controller side. So I mean, hopefully it's clear what the benefit is to being able to affirmatively assert, deny access. And the spec definitely doesn't let you do that today.
I think this makes sense. I don't know how many storage systems would be capable of actually doing this.
Yeah,
and I guess
I don't know that either.
Yeah, and my second concern is around kind of confusing existing users if we start adding similar but different RPCs, confusing existing plugin developers, I guess.
Well, so does that argue for extensions to the existing RPCs, or for different RPCs that are named something obviously different, or for just not doing it at all?
I think it's number 2, extending existing RPCs, because at least then cognitively, like, oh, this is the same call, there's a new field here.
Okay, so new like optional fields on controller publish and controller unpublish that only make sense if you have this capability. And then,
yeah, I think that would be the least confusing, honestly.
Okay, I can go that way. I can prototype.
I think also in some cases, for some plugins, they might not be able to do a force detach, like because maybe the whole control plane is just down and they have no way of doing a detach. But potentially they could do an force attach to another node.
Well, okay. I'm not sure how that would work.
So
Like,
wonder
if the control
those
plane is down, how are you going to do the attach?
seems to
So
me-
say like a whole zone is down, the control plane for a zone is down,
Mhm.
they're unable to detach from that zone, but the control plane for a second zone is still up, so they can do a force attach in the other zone.
Well, but so that presumes that like the two different zones are talking to a third thing, which is where the actual storage is, and that the third thing has some sort of access control list that it manages, right?
Potentially.
Like so what's really needed is a way for that third thing to have a way to remove something from its access control list and say, you know, this guy shouldn't have access anymore. And if you can't do that, you don't advertise the capability. But I think we should encourage plugins to have that capability, because it's kind of important for being able to fail over from dead nodes quickly.
Yeah,
and
but it
and
might be
reliably.
like that third thing in some cases could be like some internal thing that's not really exposed up to like the user control plane. Like it could be as part of force attaching a volume that it just goes and like kills off the link to the other zone.
Oh, yeah, I see what you're saying. You're saying that maybe there is a way to effectively remove something from the access control list, but only by replacing it with something else.
Yes.
So you can't just deny the access without also granting it to another guy.
Mm-hmm.
Well, yeah, I mean, that seems like a deficiency in the API, but if we had to work around something like that, I'm not sure how we could define it at the CSI layer so that the CO could get what it wanted by doing that. Because what I'm envisioning is like is a controller, you know, that runs in the CO that basically, you know, relies on something else to decide that a node is dead, and then relies on a policy to decide what to do when a node is dead. But if the policy says force, you know, cut off all the workloads and move them somewhere else, then its job would be to go sort of mark all of those nodes as, you know, force detached, and then go and actually detach all of the volumes from those nodes. And then there would have to be and the other half of this that I'm going to get to is, what do you do when those nodes come back into quorum? You have to quarantine them on the way back in, because they're now dirty, and you have to clean them up before they can rejoin. But that's the second part of this. So yeah, I'm imagining that a controller would make a decision that we think this node is dead. We would like to get the workloads off of it somewhere else. And so in order to do that safely, we're going to force detach all of the volumes from the pods.
I think on the Kubernetes side, what we've been trying to do is avoid making the logic for attaching and detaching kind of reach out and try and understand the state of the nodes. Instead, it's been kind of tied to the pod life cycle effectively. And
Well,
so
yes. So I don't want like the attach logic to literally understand the state of the nodes, but I'm imagining that, you know, we already have like a dead node detector, and if we can extend the decisions that it makes to basically indicate that this pod is running on a node that has been declared dead, then that should be enough of a signal to something like a force detacher to say, okay, someone else has declared the node dead. Someone else has decided that we want to move the pod somewhere else, so that, you know, even if the node were to come back a second from now, we would kill the pod anyways. So we've already made the decision that this pod is doomed.
And the way that decision is communicated out would be like a annotation or something on the pod.
No, I mean, I think what happens today is like the node gets tainted once it's declared, you know, out of quorum, and then the pod gets deleted, and you can just go look and see, oh, the pod is deleted. So whenever that node comes back into quorum, the first thing it's going to do is work on deleting that pod, right?
And so we could have something like the attach detach controller looking at pod deletion, and normally it just says, okay, pod is deleted. I know there's no other volumes on this node that are using this volume. Let me go and detach. They can also look at the taint on the node to see if it's you know, unavailable or whatever. And that
Yeah,
could be a signal for force detach.
the trick is going to have to be how you handle the volume attachment objects, because now there's logic in the external provisioner that will prevent you from well, I'm sorry, no, I'm getting this backwards. You can't. That has to do with deletion. I haven't thought through all the Kubernetes object side things, but I believe that there's enough existing objects and enough existing controllers that this controller won't have to be too bright. It will just be able to look at decisions that have already been made by the rest of the system, and to sort of help things along by speeding up the detach and reattach process.
Can I interject a comment?
Yeah.
This is Tom Watson, Dell. We're very interested in a solution like this, and I've been exploring a proof of concept with this, and I think I'm sorry I joined the meeting in the middle, so I'm not sure that I've heard all the conversation. What our proof of concept does is it basically looks for pods that have gone not ready and nodes that are tainted, either no schedule or no execute. And then it goes to the array and asks the array, do you have communication with that node? Are you seeing IOs from that node? Do you have connectivity to that node? And some of our arrays can answer that question very quickly. And then in that case, we want to do a fence operation, which is like your force detach, which I think we can do with just node unpublish. But we may bundle them together so we get all the volumes the pod's using at the same time. And then if you delete the volume attachments and force delete the pod, you're sorted there. We're concerned about what we may be missing with that solution.
Yeah. Well, there's two things. One, if you've implemented your controller unpublished call to actually deny access, then you're right, you are done. But the way the spec is written, you don't have to do that. So the CO can't rely on that behavior unless we add a flag that says, no, really unpublish it. And don't succeed until you're sure that that node can't access the volume. So
yeah,
that's
the idea.
The other thing I think you might be missing is if the node was alive and it never really died, you just lost communication with it, but you made the decision to fence it anyways. When it eventually rejoins the cluster, it's going to have all of its dirty buffers still waiting to flush to the actual storage. And you have to do something about that before you can actually start putting new workloads on that node.
Right, but
so,
it will be detached from the array, so it'll get
yes.
IO errors.
Yeah, but depending on the underlying storage protocol, like sometimes the behavior is just retry forever, and then
well, yeah,
when you eventually reattach, those dirty buffers can get flushed and you can have data corruption. So you got to be careful. But let me go on to the second half of this before we run out of time, because I think I have at least a direction for where to move on the controller publish, controller unpublished. So on the node side, we have node unpublished, node unstaged, and the way that they are defined today is you have to do this cleanly and safely for the most part. Like if anything goes wrong, the expected behavior is you fail, and the CO will try again until it succeeds, because you don't want to have a situation where you just detach a pod and then you lose the last 5 seconds of writes that it made or something like that, right? So usually the preferred behavior when you're doing an unpublished is do it safely. Don't lose any data as you're detaching it, because that would make people really sad. But in these kinds of situations where there's already been a failure, you've already lost some data potentially, like the storage array fell over, or network switch went away, or there's all kinds of reasons why you can lose communication between the node and the storage controller. And if the node is never going to know that that's the situation it's in, but if something else does, like the CO says, oh, I realize that this node is in a bad way, and I need to clean it up now, and while I would normally abhor losing data, I know that I've already lost data, and so I'm just trying to clean up now. We kind of need a way to call node unpublish and node unstage with a force flag that communicates this. Similar to like a umount-f command on Linux, where you're like, you know what, I don't care, just get rid of this mount, please, because I'm just trying to get my system clean without rebooting it. So I think
And
having a
and even that doesn't work sometimes, right? Depending on the driver, like you're really
right. I
depending
mean,
on.
yeah. So these force flags don't guarantee that the operations will succeed. They just express the CO's intent that it would prefer for the operation to succeed, even if data loss were to result. And you try as hard as you can, and maybe you still fail, but at least it gives the node some guidance that, like, you know what, I don't mind if I lose data. I'm just trying to clean this up. And so the node can make different choices about which system calls it uses to clean up, including umount-f, perhaps.
But I see this getting into a wonky state, right? Where, like, you've issued one of these calls and it doesn't complete successfully, but now something's dirty in the kernel, right? But like, you don't really know. And so now you're trying to run a workload and you're getting these weird failures. And,
well, no. So
just seems...
we would still have to write the spec such that, like, if you weren't sure that you cleaned up successfully, you would not return a successful result. And the CO would have to interpret an unsuccessful result as, like, this volume's in a bad state. It's not unpublished. It's not usable. It's just, it's detaching and it's messed up. Because I mean, you have the same problem today where if you call node unpublished and it fails, you can't just go back to running more workloads. Like, you don't know what state it's in. So you still have to deal with what happens when unpublished fails. And you're right, you could get into a state where you're in an endless failure loop, and the only way out is to reboot the node. But I don't think that's a new problem.
I think the like when CO can call it is when CO can call it, or like that has to be maybe more well spelled out, because this is something happens with NFS all the time, right? And but we don't know when it is safe to do a force detach. Oh, sorry, force unmount.
Well, it's never safe. I mean, that's the whole point. That you've already decided you're willing to give up your safety guarantee because you've already made the decision to move the workload elsewhere, and you've given up on those data that haven't been written yet. So yeah, it's important to recognize that, like, this is not something that you would do just for the fun of it. Like, something has already gone wrong. You've already accepted that you've lost some data, but it was more important to you to get your application back up and running somewhere else quickly and to recover from the failure than it was to just wait until the node came back.
And is there a way to express that as like an application policy in COs?
Well, I mean, that would be a CO dependent thing. I don't know how we would express that today, but today you can't even do it. So we have a chicken and an egg here, right? We have to create a way to do it before there's a way to express that you want to do it.
Yeah, it's kind of an interesting problem, right? Because we also want to be careful that we're not, like, innovating at the CSI side, right? We kind of want to we want COs to innovate, and then, we want to support their efforts. So, I see your point, right? Like, I understand the chicken egg thing, but
so to be clear, we don't have to merge my proposal. I guess what I would like to do is I'd like to write this up as an actual PR against the spec and say, this is what I would like to see happen, and then also implement the code on the Kubernetes that would consume it, and you could test the two together and convince yourself that, yeah, this is a workable scheme, and then merge it. We don't have to just merge it because Ben wants it to go in. But I wanted to start with at least a PR that would outline how we think it should work, and then build on top of that, because we got to build both sides. We have to change the CSI spec, prototype the actual new features in a plugin, and prototype the Kubernetes side that would consume it, and then test all 3 bits together and say, yes, this actually does what we want it to do.
Yeah. So something's tickling my brain here. I think, I don't know how long ago it was, a year ago, 2 years ago, somebody from OpenStack reached out, and they were pretty upset that we weren't talking about fencing. And, at the time it was like not a priority, and we said we'd get to it. It's probably still on our backlog somewhere, right? But like maybe it's worth looking at how other APIs have kind of handled this fencing issue, right? And how that might align with what we're trying to do here, because this, this whole idea of force detach and, ensuring data safety, right? I mean, this is a problem that people have solved over and over again, right? So, and, I don't want to reinvent the wheel, and it's clearly new in terms of like our specific context, right? But I guess what I'm suggesting is a source of inspiration, right?
Okay. Yeah. I mean, there are plenty of APIs that do access control, and in most of them, you have a notion of whether it is allowed or denied. And the CSI is unusual in that the only states are allowed and unknown. So like, I don't know. It seems pretty clear to me that you can find plenty of examples of access control APIs that have a clearer notion of whether access is allowed or not than CSI. And CSI was written kind of vaguely to, because that's all the COs really needed at the time. And so it's understandable why the decision was made, but I don't think it's hard to find examples of that. And then on the force detach side, you would have to look at things like, the umount-f and other system calls that people actually use when their machines get into forked states, and they're just trying to clean up. So yeah, I can.
Like in some of those node failure cases, like you might not even be able to get to the node to do like a mount, right?
Right. Well, no, so in this specific proposal, what would happen is you would cut off access to the node that was out of quorum, and then go move your workload somewhere else. And then only when the node came back, you would use these APIs to clean up the node before admitting it back into the cluster. So it would. So of course, while the node is out of quorum, you can't talk to it, but you don't need to, because they only become relevant when you want to admit the node back into the cluster, and it has to go through quarantine to make sure that everything's been cleaned off of it before it starts accepting new work. And I don't know exactly what that process looks like in Kubernetes. I mean, someone eventually has to remove that taint that says no execute, but you would have to hook into that and say, don't remove the taint until you clean up all the garbage, and make sure that cleaning up all the garbage involves these, force unpublished and force unstage calls, so that if there are dirty buffers lying around, they're really removed before you start putting new workloads on there. And I don't expect that to be easy, but
I was saying that in case of Kubernetes, like the node, when it comes back, it might start the pod that we're running before without talking to API server, actually. Because there's a proposal and design to ensure that even if a node is cut off from the API server, it should keep doing what it is doing.
Right. But in this situation, the access to the PVCs would have been denied. So regardless of what it does, it's going to fail. And until it won't get access, no one's going to call the controller publish back to that node until the CO has satisfied itself that that node has been cleaned up. That's kind of key. That you definitely wipe out all the pods that were using the PVC from the node before you ever call controller publish back to that node. Because if you don't do that, data corruption creeps in.
Yeah, it sounds like proper fencing is like a promise that a plugin has to make, or a capability it has to advertise or something, right?
Yes.
In order for this to function properly.
Yeah,
So
and I'm thinking of two capabilities, one for the controller side fencing and one for the node side. Like I can force cleanup capability.
Yeah. So this has been a really interesting conversation, Ben. I'm really glad that you presented this. It's a little after 1 right now, and I've got another SIG meeting to join. Is this something that people think should be written up as like a proposal that we can keep discussing? I mean, I think it's an interesting idea, and it's one that we're going to be forced to tackle at some point. So I'd like to see a more formal proposal written up.
Yeah, I would agree.
Okay.
Me too.
So more than just a PR against the spec repo?
You can start with a PR against the spec repo if you want to just kind of prototype and bounce ideas off of folks. I don't know if that'll be easier than trying to come up with a formal proposal right off the bat.
I mean, I'm happy to like write a document that describes the use case and the high level workflow, but like, where would that go? Do we have a wiki or something?
I mean, honestly, you could start with a Kubernetes KEP, and you can put in a section there saying, hey, these parts are going to be in CSI, and
Okay.
then once we're actually in a state where we're closer to having something that'll go into CSI, you can start a PR.
Okay.
Yeah, I like that idea because I think there's definitely going to be some CO. There's like a CO aspect of this, right? Because it's a problem
Yes.
that COs aren't even tackling right now. So I think starting
Yes.
it from the CO side as a CAP actually makes a lot of sense. Thanks, Sud.
All right. I'm happy to take it from that angle. And no guarantee this will be particularly fast because I have other things I'm also working on. But I've been noodling on this for close to a year now, and I just wanted to let you know where my thoughts were. So.
Yeah.
And
No,
this is one
great.
of those hard problems that I think we've been punting on, so I'm glad you're taking a look at it.
Yes, thank you.
Okay, well, sorry to go over time.
No problem. All right, thank you, everyone. Take care.
Thanks. Bye.